ionic or a free radical addition to the double bond is not observed with NBS if bromine is the reacting species. I repeat the question again. Why is an ionic or a free radical addition to the double bond not observed with NBS and bromosuccinamide if bromine is the reacting species? The answer to the question is because bromine in the reaction mixture is too low as a concentration. So the key is that NBS maintains a very low concentration of bromine, and that is why the competing reactions which are ionic, which involve the reversible formation of the bromonium ion, or the free radical addition reaction where the addition across the double bond can easily occur, do not happen because NBS is maintaining a low concentration of bromine, and that is why the competing reactions of addition across the double bond do not occur, do not happen. Normally it is said that allylic reactions happen, but if there is a possibility of allylic rearrangement, there is a possibility of the formation of two products. A mixture of products is formed if I have a possibility of a rearrangement reaction. So I hope this mechanism is clear. I hope these mechanisms do not happen. I've just written a mechanism, both these mechanisms which are of the addition, but actually they are not happening. What is actually happening is a substitution reaction. This is because of a low concentration of bromine. These addition products are not formed. They can be formed if the bromine concentration is increased in the reaction mixture. So let us talk about certain allylic rearrangement reactions that take place. Okay. So there is a possibility. So this obviously this bromide radical is generated using NBS. So you cannot generate a low concentration of bromide radical unless you use NBS as a reagent. So when I'm using a bromide radical, what will happen? There's going to be a carbon radical that is going to be generated. Now what happens if there is a possibility of a possible rearrangement? It rearranges itself. The question is, why does it rearrange? Because it rearranges to a more symmetrical kind of an alkene. So what is happening? There will be two products that is going to be formed. You cannot rule out the possibility of both the products because there is a possibility of a rearrangement that is happening. Because of that, bromine gets attacked. But yes, the addition reaction will not happen. It is going to be an allylic substitution reaction because I'm maintaining a low concentration of bromine. It is because I'm maintaining, because of an unsymmetrical alkene, I have rearranged it to a more symmetrical alkene, but I'm forming the allylic product. I'm forming the substitution products. I'm not forming the addition product. Please be very clear about it. I'm not forming the addition products. I'm forming the substitution products. But because there is a change of the structure from an unsymmetrical alkene to a more symmetrical alkene, I would form two products, because one would be the not arranged, the addition, the substitution, and the other would be a rearranged substitution that would happen. So I would end up in forming two products, but both the products are substitution products. So it is very clear now. So it is the addition reaction which is not happening, but only the substitution reaction that is taking place across the allylic position. I hope it is clear that the allylic halogenation is a very unusual kind of a reaction where the substitution occurs at the allylic position. So we'll talk about the